Yes, so there is a major change with respect to the Run 2 is that the number of collisions that we will collect has increased by a factor 10, the number of collisions per second. And this is a major difference for our data taking, for which we had to upgrade all the readout electronic of all the detectors. So in Run 2, we were receiving 8,000 collisions per second, and we were having a system of trigger that was filtering the data, and we were collecting a fraction of it. Now in Run 3, we jumped to 50,000 collisions per second, and in addition to that, we collect all the data that we reconstruct online. So this makes an incredible jump in terms of data volume, because what we collect is something like 1.1 terabyte per second of raw data that comes out the detector. It is absolutely impressive. And then we developed a system to reconstruct the data online and to be able to compress it. And thanks to this, we go from 1.1 terabyte to 50 gigabyte per second, which is already really enormous. Then this data sample, which is still quite enormous, will be further reconstructed by what we call asynchronous reconstruction, compressed further and filtered to select what is interesting for the physics output, and then the initial data will be deleted. This is an enormous challenge to have all this complex data model working for heavy ion collision. All those changes have been commissioned and scrutinized since last year because we were taking proton-proton data for our physics program as well. So all these have been exercised, commissioned, that have been reconstructed, and first physics results are coming out. What we are doing is that during proton-proton we can push the quantity of data we collect to a level where we have in the detector the same amount of charged particle as we expect to have in lead-lead collision. And thanks to that, we know that all our system is correctly designed, and that the data volume that we will receive will be correctly handled by the system.